and I will try to continue. With our copy of Skyblue. As you can see, it has on top serial number 02, so it's my Skyblue. So first, let's switch on the measurement. This is the screen with switched off measurement, and I have some preset which is corner, and we will see probably a bad image here because I put a very shiny object. I will try to show it later because it's in the other room. And this very shiny object is delivering this kind of picture. So what I will do now, it's a fillet object. What I will do now is to go to presets, make a new preset. Let's call it test fillet. Of type fillet, and then I return back to view and I select the newly created preset. The image is already much better because the exposure time which I chose and the gain are much less by default than this one which I have in the corner, which are 8 and 4, and in the fillet there are 2 milliseconds and 1 decibel gain from the sensor. I can still try to improve this image, and I will play with these 2 and with the point sensitivity parameter to get eventually better results in the point finding. The point finding, the points which we find are these red dots. I can switch them off, so this is the original image and these are the points we are finding. If we find all the points up to here with this bad reflection which we have from the object, it will be better. I will try first to increase the gain and see what will happen. Let's put the gain to 5. Okay, it's worsening, so I can put it to 2. Again is bad, 1. This is the lowest possible gain. Now I can play with the exposure time, and I can reduce it from 2 to, let's say, 1 millisecond. It improves. I can go even for smaller time, like 0.1 millisecond. Okay, I stop to see the object, because the object is actually this thing, and this is the reflection of the surface, which can happen, unfortunately, in many surfaces. This is an aluminum surface, and that's why it is so bad. With 5 I get not so good results, so let's return to 1 or to 0.8 for example, or even a bit less, 0.6. No, it's too much, so 0.8. And now I can play a bit with the point sensitivity. The higher the point sensitivity, the less points I will find. so the noise will be removed. And I have to be careful, of course, not to remove too many points. So I can put, let's say, 5. Okay, all my points are gone, almost all. Let's put now 2. I get back many points. Let's have 1. I get already part of the noise, so let's return to 3. 3 was a good value, the initial value. There are some noise here and here, but this shouldn't be so critical for the finding on the next step. We can go back to object, and as we can see in the object, we see the lines, and we see, so these are the same points after the geometric transformation. This screen here draws the picture in millimeters, so this is the actual world space of the camera. And here these pink squares are 10 millimeters each, so you can easily measure and adjust the object. I put again back the segments. What is the situation with the segments? I have 2 relatively long segments and a breaking here which appears from time to time. First I can try to improve that a bit by raising again the exposure time. Let's put it to 1.5 milliseconds. Okay, the lines are much more stable now. And I can as well touch this line sensitivity parameter. The higher the line sensitivity, the stronger are the requirements to produce the lines. So they will be more stable, but eventually I will lose lines. For example, this way the lines become more stable. But if I put, for example, 90 here, I lost one of my lines. So I have to go back to, let's say, 30. Okay, I have a stable line. So out of a relatively bad image, I went to a relatively stable image of my fillet. Let's see what else is to be adjusted. Now we have to go to the geometry of the objects. These 2 parameters are again related to the line finding, and here is the geometry. First I have 0 for my absolute angle. The default value here should be different, and we'll change it with the next build. It should be, for example, 45 degrees, and I got my tracking point. I can reduce a bit the absolute angle tolerance, because if the robot is moving, it can change the angle towards the fillet, but probably not so much, not like 45 degrees. So I can reduce that to 25 degrees. And now I can correct the absolute angle here, the angle between these 2 plates, which is, once the tracking starts, I see the measurements. It's measured like 85, 86 degrees. So I can put here, for example, 85 degrees to my object, and the tolerance, as the object is stable, regardless of the orientation to it, I can put here 10, for example, expecting that this will not change too much. And now we can see how stable is our tracking point. It is varying like 0.1 in both directions, in TPX and TPZ. By the way, this is another thing, the Z axis. Why it is Z? Because the Y axis together with the Y axis will form a right coordinate system, not a left coordinate system, which is the proper coordinate system we need. And the y-axis is a perpendicular axis to the laser plane which we are seeing. Okay, so the tracking is okay, and I can save my preset, and later from the robot I can switch to this preset for that object. Yeah. Okay, I will pause now and go to the other room to show you. So, this is my object. As you can see, the reflections are terrible, and out of these reflections it looks like this. It's a piece of aluminium which is not exactly okay, but you can see what my phone is seeing. The actual thing which the camera is seeing is this laser line, not the other reflections. And this laser line is the laser line which we need. The others are reflections from the front of the camera to the object and back. Okay, so I will change this object to another object, which is a black metal object, and we can see what are the results with this object. I'm going back to my computer so that I can show you on the screen the client behavior. Okay, so practically with the same settings we have the tracking, not so stable as it was, the other was. Actually it is stable enough. Looking in the tracking point, the tracking point changes in the 0.0205 of the millimeter, so to 50 microns, which is relatively good. We can try to adapt or adjust something. We have quite a straight lines here, quite a clean image with the black object, so not so much to do to improve that. Maybe we can change this line sensitivity to a lower value, like 15. And as I want to see the bottom better, I can try to touch the maximum allowed gap in the line finding, which is 0.5 millimeters. Let's put it to 1, and now I have more stable situation. Even I can put 1.5 millimeters, and my object is already, the segments of the object are stable, and of course the tracking point is quite stable, in the order of 0.05, like 50 microns precision. Yeah, the other values which we can see here are the gap. The gap is the distance between the end of the left and the end of the right segment as they are found. And this gap is a value which we measure to 0.2, 0.5 millimeters, so a floating value, but so small gaps are probably not interesting for the tracking. It would be interesting if the gap is big. And we have a limit for the fillet up to 10 millimeters, not more than 10 millimeters of gap we allow for a fillet. Of course, this can be adjusted, and we can put this maximum here in the geometric parameters if this is better. and this is the left and the right segment length of the gap of the fillet, sorry. Yeah, so let me stop with my first attempt to do a video, and maybe you can tell me, is it better this way of communication or not?